All right, so here's the first one I want to look at. First one I want to look at. So there's two kinds of questions, and I'm just gonna really the question is not the stuff in the red box, but there's another question on the review, and there's likely to be one like this on the test, like the red box one. The red box one just means that we're not going to go all the way to the answer. It means we're going to stop after completing the square. So let's do the problem below, only when we get to the step where we would be answering a red box question, we'll put a red box around it. So we can just kind of identify what the answer would be like if those were the instructions instead of actually solving the whole thing. Does that make sense?
Yeah.
Okay. All right, so what about this guy? We're going to solve by completing the square. So what do we do? Good. Okay, so first we're going to subtract 52, and then what comes next? Divide by 4, because we need to get x squared plus bx by itself on the left side, right? So we got those two steps.
Couldn't you do the plus divide by 4 then subtract?
You could, but you really don't want to. You really don't want to, because sometimes that's going to make the algebra a little bit tougher. Okay, you'd rather go in the order, and really this order makes sense, because it's the same order we would go in if we were isolating a variable. And we're not really truly isolating a variable, but we're trying to get x squared plus bx by itself at least, right? So it kind of makes sense that it'd be compatible with this way of thinking. So first step would be we're going to subtract 52, and then I get 4x squared plus 24x equals negative 52, and then you told me divide by 4, which is correct. Okay, and that's going to give us, you tell me, x squared plus 6x equals negative 13. Okay? Okay, now what? Okay, good. I've got to add half of b squared to both sides to create a perfect square trinomial over here that's going to factor properly, right? So what's b? 6. Okay, what's half of b?
3.
So what am I adding to both sides? 9. Good. I'm adding 9, which is really just 3 squared to both sides. Okay? And what's that going to factor into on that side then? Good. X plus half of b, which is 3, squared, equals negative 4. Okay, so that's the red box answer then, isn't it? Right, let's put a red box around it. So if we were doing those instructions, that would be where we would stop, okay? But we're not. We're moving on. So now moving on, what do I do to solve for x here? Square root. And this really just becomes kind of an easy 4.5 kind of problem, doesn't it? We're just isolating x. So we square root both sides, and what's that give us? X plus 3 equals, okay, well, what do I got to remember before I do anything else? Plus or minus? Plus or minus the square root of negative 4. And if I'm square rooting, I don't want to do that, it's going to mess it up. If I square root negative 4, what's the answer? Square root of 4, which is 2, good. And then I've got the negative inside the radical, which becomes an I, right? So I get plus or minus 2I. And then last step, subtract 3. Good. So we end up with x equals negative 3 plus or minus 2I. So in Moodle, what would I put in the answer box then?
Negative 3 plus 2i.
Good.
Yeah.
Negative 3 minus 2I. Okay? Good. All right, so last one, we want to solve using the quadratic formula. So what's the first step? Get everything on one side, okay? So to get everything on side, what am I gonna do?
Subtract x squared, 6x.
Good, and that's gonna give me okay? So there's my quadratic equation in standard form, right? And if I have a quadratic equation in standard form, so if ax squared plus bx plus c equals 0, then what does the quadratic formula tell me? X equals all divided by 2a. Good, okay? So we'll just plug and chug then. So really that's all we have to do. So x equals, if I apply the quadratic formula, what's negative b? Plus or minus the square root of 18 squared minus 4 times 2 times 3, right? Make sense? 4ac. All divided by 2a, which would be, okay? So that gives me negative 18 plus or minus the square root of 324 minus 24. So what's that? 18 squared is 324, right? And then 4 times 2 is 8 times 3 is 24. So I get 324 minus 24.
300.
300. All over 4. So that gives me negative 18 plus or minus the square root of 300. Well, I just have to do my factor tree on that, right? But this is a pretty easy one to do. If I do 300, what would be real convenient values for me to factor that into?
100.
There you go. I could do a 3 and a 100. And 100 is great because 100 I could break up into a couple of what? Tens, yeah. So we're going to get a couple of tens. Oops. We're going to get a couple of tens and single 3. So I get negative 18 plus or minus 10 radical 3, right? Divided by 4. And then I could split that into 2 separate parts. So I get, I'm gonna split that denominator up and get negative 18 over 4 plus or minus 10 radical 3 over 4. Now how could I reduce those? Okay? Plus or minus. And then what am I going to do with the? Okay, now does everybody get that? So I've got 10 times the square root of 3 over 4. I can reduce like factors, can't I? So if I were to divide the top and the bottom by 2, 10 divided by 2 is going to be 5, and 4 divided by 2 is going to be 2. Okay, do you get that? I don't have to do anything with that square root of 3. It's just like an x, right? When I have 10 times the square root of 3, what's that mean? 10 square roots of 3, right? Divided by 4, just like I would have 10 x's divided by 4 if that were an x. So I can reduce the 10 over 4 just like I could if that square root of 3 were an x. Okay? Whenever you get a number that's multiplied by something that's coefficient, it really is just a number of those things. Okay? So then our final answer just looks like 5 radical 3 over 2. And there's both of our answers, one for the plus and one for the minus. Now we just separate and remove them. Okay? Make sense? All right. I'm done. You can use the rest of the time to work and get questions answered. If you want to finish a test up, just come into the front row. Sure. Go up a little bit. There you go.